Hey everyone. So after we have set up our data set, including this information about word usage of specific key terms that we identified previously, as well as the author information of the Federalist papers, we are now ready to proceed to split up our data. And the way we want to split up our data is essentially for this classification task is to split it up in a training set, or what is often called in kind of data science applications, a training set and a test set. The idea behind the training set is this is the part of the data where the authorship, in our case, in our classification task, where the authorship is known, and we can kind of try to kind of fit the model that predicts authorship within that sample. So those are in-sample predictions. And as I mentioned previously, we are focusing on distinguishing authorship by Hamilton from Madison, right? So we're going to create a data set called train.dat, and that will be a subset where the authorship is either Madison or Hamilton, known to be Madison or Hamilton. And then we need a numerical representation of this distinction, and for the purpose of the model that we're going to fit now, we will create a score that will be 1 for a essay that was written by Hamilton, and -1 for an essay that was written by Madison using the if-else command. So that's our training set, and then we will also need a test set. Oops, no, that was the wrong one. There you go. The test set is the remaining part of the data where the authorship is unknown, and that's where we actually want to make predictions kind of out of sample, right? So we use one part to kind of learn the relationship between language use and authorship, and then predict out of sample on the test set who the likely authors were of the 11 contested essays. Right? So our test set is then the subset of the data where the authorship was contested. Okay. So after we've done that, now we move to actually fitting the model. And again, we're doing this in a very simplified fashion. Of course, there are more advanced methods, but based on what we've learned so far, we'll just look at how we'll just use a basic linear regression of the score that is 1 or -1 for authorship of Hamilton versus Madison. And we're just using, in our case now, even just 4 of the 8,594 possible word rates that we identified, or that we extracted from the Federalist papers. Okay, so our model has a dependent variable, which is score, and then we use 4 different terms upon there, consequently, and whilst as terms that again are kind of like identifying habitual word usage that are not necessarily required to convey specific content, but are more kind of idiosyncratic parts of idiosyncratic writing or speaking habits, right? So that's the goal that we want to focus on, and we will examine whether those will help us to identify authorship. And we do this using the train.dat subset of our data frame, right? And so we get a set of coefficients for each of those terms, and just very briefly, when we kind of think about, of course, we're not really interested in interpreting kind of the like substantively, like interpreting the coefficients themselves, but it's nevertheless kind of useful to look at the coefficients and see whether what the underlying patterns are. Right. So remember, when we set up this data frame, we defined the score to be equal to 1 if the authorship was Hamilton, and -1 if the authorship was Madison, right? So every positive coefficient, well, every positive coefficient for upon, there, consequently, and whilst means that the higher the rate of each of these terms, right, the more likely, the higher the score, which means the more likely this this document was authored by Hamilton as opposed to Madison. Right? So in other words, across all the letters that we have, across all the Federalist, across all the essays, Hamilton was used words like upon, there, upon and there more frequently relative to the overall document length than Madison, and Madison used consequently and whilst more frequently than Hamilton. Right? So in other words, if the proportion of whilst and consequently, if those terms appear more frequently in a document, we would predict that Madison wrote, or we were more likely to predict that Madison wrote that essay. And if it includes words like upon and there, it's more likely to include, to be written by Hamilton. And also note that the effect size differs quite substantially across these terms. Like a term like there, where you would probably expect to be less idiosyncratic, the coefficient is relatively small, whereas whilst, which of course is more idiosyncratic in terms of language use, seems to be more clearly, or there appears to be a stronger imbalance in the relative usage of that term, right? And so this is our model. We have these coefficients now based on the training set. And we can use that now to kind of predict, use the test set where we don't know the authorship, and basically you just plug in, use that as a new data frame, plug in those values for the word rates for those specific terms, and then predict the score that is our outcome variable, and thereby create a prediction of who's more likely to have written each of those letters. And so that's the step that we get to in terms of prediction. But before, we want to talk a little bit about evaluating the kind of the quality of our predictions in sample, right? So remember that we have distinguished our score, which was 1 or -1, from the author information. Or we kind of use that to kind of numerically represent authorship by creating this -1 to 1 score. And we can now compare the predicted score to the actual authorship in our training set, right? And this is kind of similar to in previous example, we kind of talked about distinguishing predicting a vote margin from a winning a state when we talked about polling predictions, right? So the kind of the predicted value on the score, kind of you could think about it as some underlying latent scale that is kind of similar to the vote margin. And the actual winning the state then is equivalent to having more than 50% or less than 50%. In the terms of our score, it would be larger than 0 or small or larger or smaller than 0, and we would predict Hamilton or versus Madison as authorship respectively. Okay, so here what we're going to do is we will look at the fitted value, so that's kind of just the model fit for each observation in the training set, and we just look at whether this is larger than 0, which would imply basically authorship which means we would predict authorship by Hamilton, and we compare this with our score, which is just the numerical representation of the true authorship, right? And so we can see that at least in sample, based on the model that we learned, we can, you know, perfectly, the predicted values kind of correspond to the actual values of the dependent variable. So in other words, the model kind of accurately predicts, or the predicted values are kind of close enough to the actual observed outcomes, right? But this is in sample, so this doesn't really tell us all that much about how well we can predict the authorship of new documents, right? It's not really all that impressive that we're able to predict the authorship of a set of documents where we already knew the authorship, right? So ultimately, the real test of a classification model is not to predict the data that we use to actually train the model, so to kind of estimate those coefficients, but to use it to predict data that it hasn't seen before, right? So now we're going to do the same thing. We're going to predict or compute predicted values for a new data set, which is this testing data where the authorship was contested, okay? And again, we're going to we're going to dichotomize that and use as a threshold 0. So if our predicted value is larger than 0, we will predict that that the author was Hamilton, and if it's smaller 0, then the authorship is predicted to be Madison, right? And so we see that out of the 11, this is now the output here of this the statement, out of the 11 documents, out of the 11 essays, only one is predicted to be written by Madison. All others are predicted to be written by Hamilton. So who probably wrote the contested Federalist Papers? According to this model, at least, the prediction would be that most of them were written by Hamilton. We can plot these results to get a better overview of kind of how this prediction looks like. And specifically what we're going to plot here is on the on the x-axis we have the actual number of the essay, right? So basically just a range of all the letters. And then on the y-axis we have our fitted value. So based on the model for both the training data and the test data, okay? Sorry, for just the training data first, right? And then we identify documents written by Hamilton as red and documents written by Madison as blue, okay? And then we add additional data points for our test test set. So those are the contested documents, and we add our predictions that we computed previously. So those are kind of the predicted scores for those observations. And then we'll add a horizontal line at 0 just to kind of make sure, identify the threshold where we predict authorship by one versus the other, okay? And this is the result. So we have on the x-axis the page number. So the individual essays basically, and on the y-axis we have the predicted score, and red and blue identifies actual authorship by Hamilton and Madison. And we see, and I think I kind of flipped it around in the previous slides because I kind of confused whether one was Hamilton versus one Madison. But essentially what we see here is that the unidentified documents with contested authorship kind of all cluster in terms of their predicted score very close to Madison, or comparable to Madison, and most of them are therefore predicted to be written by Madison. Okay. There are other additional kind of ways to evaluate the kind of quality of our predictions, and I'm going to go through those fairly quickly. Of course, we, based on this, we don't really know, since the authorships here are contested. We can't really evaluate, well, how certain should we be about this prediction? How convinced are we to correctly predict each of those essays to be written by Madison? And so there are a couple of different ways of looking at this to evaluate and kind of examine these out-of-sample predictions and try to assess the quality of those out-of-sample predictions. So one thing we can, for example, look at is to evaluate the jointly authored papers rather than just the contested papers. They were written by Hamilton and Madison, and here the argument could be, if those were jointly authored, all of you who have worked on collaborations in your class papers know that there is not always a direct, perfect balance in how much each collaborator contributes. And so one interesting question could be, if there's a co-authorship, to what extent is the language more resembles one author more rather than the other? And in this case, and I now have to kind of think again, so these three kind of jointly authored documents are more resemble Madison more again. Okay. Another question we could ask, for example, is whether John Jay, the third author, writes more like Hamilton or Madison. And one way to do this would be to just examine the predicted score for the documents where we know they were written by John Jay, and we see that those are also more like Madison, or more similar to Madison, in the sense that the score would predict that they're they are more similar to Madison than they are to Hamilton. Okay. All right. There are a couple of other kind of considerations to think about. Think about ways to kind of evaluate the quality of your out-of-sample predictions, and one way is to kind of fake, or kind of think about ways to provide an assessment of how good we would expect to be out of sample, right? So one important standard to kind of assess out of sample predictability and quality of predictions is to kind of have an accurate baseline. Even if you didn't have a model whatsoever, how good would you expect, just to randomly guess, for example, right? And one key way to kind of assess the sample or what this out of sample performance would look like is to use cross validation. And that's again one of those like central techniques that is used throughout data science. And the idea behind cross validation is to basically remove some of the training data that you have, use the same kind of procedure that you used before on the smaller subset of training data, and then pretend that the left out training data is actually your test data, and use that to evaluate the quality of your prediction, right? So you're kind of like faking out of sample. You have actually a larger training set. You have labels for you know the authorship for all those documents, so to speak, but you're just pretending that you didn't know some of those authors, and you're learning, you're training, you're fitting your model based on the remaining documents, and then predict the documents that you already know to kind of see how well you're doing, to kind of give you an idea how accurate your assessment is for the truly unknown, unlabeled data where you actually don't know the authorship, right? So in the book, there's a little bit more discussion where they check how well we expect to be able to predict authorship using the training set, and so make sure to check out those examples. There are a couple of other useful things with cross-validation that I'm just going to mention really briefly, and maybe we could talk about those more in the Q&A session, because I know we already have a lot of videos and a lot of content for you now. One thing is to look at sensitivity testing, so examining specific predictors, leaving out some of the documents, and examining kind of the predictive, or examining how the coefficient for one specific predictor changes over individual cross-validation sets. And again, we can talk more about this in the Q&A, in our next Q&A session. And then we can also kind of focus, rather than focus on specific predictors, also focus on specific documents, and kind of go through this cross-validation logic where we leave out some of the documents and then predict for the remaining ones to to evaluate how certain we are that, for example, Hamilton and not Madison wrote 55. Okay. So all this cross-validation, and I know I kind of went through this relatively quickly because I don't want to bombard you with too many videos, but these are kind of important examples of kind of trying to assess uncertainty around the estimates, right? And this is something that we haven't talked about yet when we talked about, you know, OLS models and model interpretation. But this is the crucial aspect that we're going to come to now at the you know, towards the end of this semester, right? So, for example, in this example with authorship, if history had been a little bit different, our coefficients would have been a little bit different. If authorship would have been slightly different, or some of these essays would have been written by different authors, and you know, if the coefficients would have been a little bit different, of course our predictions would have been a little bit different, and the question is how different, like to what extent would this make a difference, right? To what extent would this change our predictions ultimately, and kind of the ability to quantify how much these predictions change under, you know, kind of changing or with changing replications, or kind of change, or with kind of a repeated sampling, for example. That's ultimately where kind of probability theory and kind of quantifying uncertainty comes in, and that will be one of the you know, that will be kind of the key topic for the remaining weeks, is to quantify how certain we are about our conclusions, as in this example with authorship, and how much uncertainty is there around our estimates and things like that. Okay, I'll leave it at that. I'll add a quick video and to wrap things up, but other than that, we're good for this week, I think, and I'm looking forward to our next Q&A session.